Hello everyone, welcome to my YouTube channel. Today we will do some practical because a lot of things we already discussed on the theory side. So today we'll do the actual practical with linear regression and our focus will be the standardization. Why standardization is so important for linear regression that we will try to explore today. Okay, so let me start actually. So I have already a data set which is very simple. Actually, it's a dummy data set just for this class we prepared, and it has data like this. So it has data with age, income, and then basically the bird rating. It's nothing but just based on the age or income. Do you like the bird? How much percentage do you like, something like that. So it's basically kind of a continuous variable. Just think about that way. Okay, it's a dummy data. Just don't think on a real perspective. Main intention is to show why the standardization is so important for linear regression. So what I next did, I just created some histogram on age and income, and basically it is telling me some story that okay, the whatever data I have, the maximum frequency is actually between 30 to 60 in this kind of range, whereas the incomes, whatever data I have, that is between like around I think 55 to 65. In this range I have the higher population or sample of data. Okay, then I just created a scatter plot using the age and income, and it's kind of I'm just trying to check if I'm getting any relation between this. So it's not really telling me any big relation that okay, as age is increasing or something like that. Um, Probably it's telling that as age is increasing, the kind of income is little bit dropping, something like that kind of story. Okay, but not a very high correlation between this. From this we can see. Okay, now the interesting thing. Now, before I really jump into the standardization, because from the coding point of view, it's just like this. In Python, we have a package, we can just use that package and the data will be standardized. Okay, but you need to understand why we need standardization. Now, if you are familiar with the linear regression kind of a model, you know that your function will be y equal to some intercept and then the coefficient. So there are two parts. One is intercept, another is the coefficient. Now, what exactly the intercept tells us when we build the model, what exactly the intercept tells us, that's very important. Intercept parameter is interpreted as the mean of the response when each predictor is zero. This is very, very important. That what it is trying to say, that it's trying to say the mean of the response, like whatever response I have, like in this case, response mean this target variables or output variables, whatever you want to say, but this is the response and these are the predictors. So these are the features. Okay. So intercept parameter is interpreted as the mean of the response when each predictor is zero. Very, very important concept. You need to understand this. Okay. Now, think about this. Each predictor is zero. So, if for any feature, if zero is not a valid value at all, then this intercept value is not giving me the right picture actually. Like for example, in this case, before I go that, I think everybody is clear what is predictors. Predictors in this case, age and income. Response is the Bard rating. Okay. Now in this case, do you think age can be 0? It's not possible, right? Age cannot be 0. So then whatever this definition is actually not satisfying my hypothesis. So the parameter is interpreted as mean of the response when each predictor is 0. So in this case, if I consider age is 0, it's not satisfying. Okay. Similarly, what exactly slope is telling me? Slope parameter in a multilinear linear regression is interpreted as the average change in the response for a 1 unit increase, or if it is negative, then decrease in the value of corresponding predictors, holding other predictors constant. So now in this, so you kind of understand, right, what the slope is telling. Slope is basically telling that 1 unit of change of this slope, 1 unit of change of my age, what is the impact on my response? 1 unit of change of my salary, what is the response of my, what is the impact on my response? Makes sense, hopefully. So now we have two problems. One problem that I already mentioned, that 0 is not meaningful value for the age predictor, right? Absolutely. I mean, in my data, there is no 0. 0 is not at all a valid value. So this is one problem. And the second problem is, do you really care about how a $1 increase in the salary will impact this Bard rating or this response variable? Probably rather will care if it is 1000 or something a little bit more, right? Probably not. It would be more convenient to interpret the change with respect to the bigger jump into the income, say $1,000 increase, right? So these are the two problems can arise in your case also. Whatever data you are working, this similar kind of situation you might face, that okay, I have some of the predictors where 0 is not a valid value, and I have some of the predictors where I really don't care if just 1 unit change, what is the impact, right? So this kind of situation, when it arises, we need to do the standardization. Now standardization, when we are doing the standardization internally, it is doing two-step process. It's actually doing a two-step process. What exactly the standardization? So that's why I will go a little bit slow and I'll show you, instead of just using the Python code and show you the standardization is done, instead of that, just to explain. So first problem is this one, right? 0 is not a meaningful value for the age predictor. So for that, what we have to do, to better access and interpret the effect of the predictors on the Bard rating, we can change our scales, and that's basically the standardization. Let's start centering our data, which requires setting the mean of each predictor equal to 0, and then we can subtract the mean value of each predictor from each value. Okay, hopefully it's clear. So what I'm doing in the next step, I'm just calculating the mean of age and mean of income, subtracting the data and centerizing the data. And this, if you now check the data once again, it will basically plot, scatter plot. You will see that your data has now 0 as a meaningful value. Now 0 came into the value with a meaningful interpretation. Okay, that is called the centralization. When we are doing the standardization, this is also taking care. You don't need to do it separately, like centralize the data or anything. This is getting taken care when we are using the Python package. Okay, I'm just trying to give the concept. Okay, so that's the way you can do the centralization of your data using the zero centered actually. Okay, clear? So now if you see the data, your data will look like this, where you have some zero values. It's basically on the left hand side, right hand side of zero. That's basically your zero centered distribution. By chance, if it is still not clear, like why this zero centered or this intercept calculation is so important, there is one very nice article here mentioned by Karen Grace Martin. Thanks to him or her, but very nicely it's explained. Whatever I have explained, it's very much nicely explained here also. Okay, so if I have mentioned this here, by chance, if you're referring my GitHub page, I'll put it into that GitHub page and you can take this link, so it will be helpful. Also, I will put it into my YouTube channel so that you can click on this and you can read a little bit more why we are doing this zero-centered thing. Okay. No need to worry. You don't need to write this much of code when you are doing the actual standardization, because I mentioned to you in Python, there is a package which can help you and the standardization can be done just like this. Okay. But you need to understand why you are doing these things, because it can come in any question. Now, the second thing, okay, we do this thing that, okay, we make our data more like zero centers. This is called centering our data to this way. Now, still the range of predictors is very different, right? If you see, the range is actually from minus 200 to 20,000 to 30,000, here minus 40 to 40, so completely different range. And this kind of range, as I mentioned, that's still the same problem, right? We are probably not care about like 1 unit change on this kind of range. So range is still different. Now, what is the solution? So we know that the spread of a variable is represented by the standard deviation. Therefore, if we divide the centered predictors, whatever we numbers we've got, the centered predictors by their standard deviation, the new standard age and income variable will both have the same spread. And process of both centering and scaling the data is called standardizing the data. Hopefully makes sense, right? So that's the entire process. So basically, first we are centering the data, and then we are dividing the centered predictors, dividing this by the standard deviation, and then we are getting the standardized data. Correct? So we are solving two problems, and for that we have two steps, but all these two steps will be done by this package. So we have a standard scalar package in the pre-processing in sklearn. We'll just import that, create an instance, and then we'll fit our data into this. Once you fit the data, after that, I'm just creating again a new data frame with this fitted data, and then I'm displaying this. So now look, your age range and your income range both are almost in the same range, minus 2 to 2, minus 2 to 2. So that's basically the standardization, and it's very important for linear regression, and I will say on any algorithm, even for deep learning, like where we have any kind of gradient boosting kind of problem in the algorithm, there you have to use the standardization process. Okay, so I think kind of it's clear. So from the coding point of view, it's very simple how you can standardize your data. So that is the way you can standardize your data. Just you have to use the standard scalar and just create a data frame. You're done. Your data has been standardized. Now, when you will do actual um, model building, you'll have test data, train data. You have to do it for the both. So that's remember all those things. But this is again very simple way. If you want to do it, you can use this kind of thing actually. Okay, so basically now my data looks like this. So this is my standardized data, and using this, I am solving both the problems. I am solving the intercept problem and I'm solving the slope problem. So this is very, very critical. That's why I'm explaining it slowly and explaining in this way rather than just mentioning, okay, for linear regression, you use the standardization. Try to understand why you're solving, what are the problem you're trying to solve using the standardization. So that's the main intention. So note that this should fix the interpretation of the slope parameters. Remember, now the interpretation part is coming. If we are using the standardized variable, that's mean if we are using these variables, then our interpretation will change. This is very important. 1 unit increase would be a 1 standard deviation increase. Previously, what we saw that 1 unit increase mean what is the straightforward increase. But here, 1 unit increase on any predictor is basically how much it will change on 1 standard deviation increase. And I'm talking about increase, but it will be increase and decrease. So we just did a bunch of math. Now people can have a negative age or income because I can see here negative age and negative income. Of course not. Remember this. Don't get confused that your age and income is now negative. We have just changed the units. The new units measure income, but centered at 0 with standard spread. In addition, the order of the data is still preserved. Let's visualize the resulting predictors, right? This is very crucial. Okay, so what I'm doing basically, I'm again using this data frame, this new data frame, and I'm just using those predictors, and I'm just plotting this graph. And look, absolutely there is no change. If you check this, there is no change. That means standardizing is not changing the underlying data. It's just changing the underlying unit, but your the density of the data is not at all changing. Okay. But what exactly then changing? It's changing basically my intercept and slope values. That's very important to understand. Okay. Um, what is wrong here? Okay, I think that's why. Just slope. Am I doing anything wrong? Word underscore slope invalid syntax. Where is that syntax? Oops. Come on, come on. Oh, okay, got it. Okay. So what I did after this, I just separately calculate the slope for I don't see the bird slope actually. This is yeah. So basically, I just created a scatter plot with income and bird, and what is the slope I calculated, and created a graph also, scatter plot using that. And I did the same thing for the standardized data. So this one actually with the original data, that's why I'm using the original data frame. And this is my standardized data. And you will see this coefficient values are changing significantly. Okay. I don't know how much you're familiar with this thing. So that's why this is my way of interpreting. That's why I make it a little bit simple rather later part. because in my channel I have already covered the statistical models. So if you use the statistical model with your original data, you will see that your intercept, age, and coefficients value will be different, though your R square and everything is like this, okay? And if you run the same thing for your standardized data, then your R square and adjusted R square, there is no changes happening. But your intercept, age, and income is definitely giving you the right value. So this is very important aspects. Um, so that's why standardization is so important. So I hope this probably explain you. Just remember, when you use the standardized predictors in your model, then your representation, the unit increase in standardized predictor represents a change of one standard deviation from the mean of the predictor variable. This is very important change. Like when you are standardizing, then your interpretation will change like this way. Okay. So hope you like it, because a lot of time what happened, like when you work as a data scientist, then there are two things. Like one thing is you just need to predict the output. Another thing is you have to explain the relation of all the features. And that time, this is very important. This for linear regression, especially this intercept feature, all the features, values, slope values are very important. And that's why standardization is very crucial. And I hope kind of understand why we are doing the standardization, what are the problems we are trying to solve using the standardizations, and how after doing the standardizations, how I will represent the slope value and how I will represent the intercept. Okay, thank you so much. Hope you like it. If you like it, just give me a thumbs up or subscribe my channel. Your support will help me to grow. See you in the next video. Have a nice day, blessed day. Bye.